Good morning, everyone. Thank you for being here this morning. I know it's the first talk of the day, so everyone is excited. The week is going to be a long week. Drink a lot of coffee, drink a lot of water, take some rest. And it's a pleasure to be here at the Edge co-located. My name is Julia. I'm a global technologist at Veeam. I'm also a CNCF ambassador and AWS container hero. I work a lot in the container space, and I'm here today with Candida.
Hi, so my name is Candida Valois. I'm the field CTO for Scality.
Yeah, and we're here today to talk about something that's becoming even more critical every day, which is managing our Kubernetes environments at the edge. So there are a lot of constraints, and we need to rethink how we design, how we deploy, and how we make it more resilient because of all the attacks, everything that's going on in this space. So first, we're going to talk mostly about a use case from a client, and we've changed some details. We don't want everyone to know who it was, and so we created a fictional company called Retail Co. And basically, it has the same things as the real client. It's a global retail store with more than 500 stores all over the world. And they rely on interconnected systems with Kubernetes at the edge. And the interconnected nature of the systems means that any disruption, especially downtime, is really bad for customer trust, for, impacts sales, impacts everything, operational efficiency, and it's, an important topic to talk nowadays. Talking a little bit about their architecture, to enhance responsiveness and the customer experience, they were deploying edge Kubernetes clusters for the computing power, and that enabled them real-time data processing at the store level for functions like automated restocking alerts, and also they had personalized promotions for the customers, while integrating with cloud-based analytics for deeper insights. They had also an application that was hosted in the cloud. But the thing is that with all this architecture, they were on the edge. This is not the same as running fully in the cloud or in data centers. Like I said at the beginning, the edge has its own constraints. So there are challenges like resource constraints, limited compute, memory, storage. Also, the network reliability can be unpredictable with intermittent or even sometimes no connectivity. And the expanded footprint of edge devices creates a larger attack surfaces. And that's what happened. This is what created an ultimately vulnerability that was exploited by attackers. So it was exploited by a ransomware group, and it was a huge attack on the company. So first, the attack began by a simple phishing email. We talk a lot about ransomware attacks in our companies, and usually people are the first entry point for ransomware attacks. That's why we have to train people, our employees, every time. And that allowed the ransomware group to propagate across retail edge Kubernetes clusters. And then on day one, the ransomware encrypted all the persistent volumes, disrupting the critical application workloads. By day two, that resulted already in chaos. So all the inventory system was down. The point of sale system as well failed. There were empty shelves, customer complaining, and then, leaving the stores. They were very dissatisfied. And by day three, the IT team discovered that their backups were corrupted, so they didn't have any clean point to restore from. So this was a big problem. And then talking a little bit about their backup strategy, they had critical flaws that contributed to the severity of the attack. So the attack was already bad, but because of their backup strategy, they weren't able to successfully recover. So they had manual snapshots that were stored locally. Also, they didn't have any immutable storage, so that's why it was easily corrupted. And they didn't have any offsite backup in the cloud or in a data center. So all of that were problems that kept adding up. And we usually, when we're talking about backups, we usually talk about a famous 3-2-1-1-0 rule, which is having 3 different copies in 2 different medias. One of them needs to be offsite, the other one offline, immutable, or air-gapped, and the 0 is for 0 errors, so you need to be always testing your backups to make sure that they're recoverable. And obviously, they didn't follow this rule. They didn't have a good backup strategy. That's why it was devastating for the whole company.
So that sounds very depressing, right? So the good thing is, they went after all this happened to them, to this specific company. They were, of course, some of you guys know there's a process internally that needs to happen in definitely different parties that needs to work on this. But there are some things that they needed to rebuild. They look at their infrastructure, and then they were like, so what are the things that we need to do so something like this doesn't happen again? There are many companies, including this company, that as soon this happened, they lost millions of dollars until they were able to recover again. So that's definitely a big deal for a lot of these companies. So there are 4 things during that period that they needed to build and needed to have in place in order to have a more resilient type of environment. The number one is being able to, as Yulia mentioned, being able to talk about and have an immutable type of infrastructure that will allow them to set up and have all these different applications. This is the more critical applications, right? This is applications that are running on your Kubernetes environment. This is critical to every single one of this business. So they needed to make sure that when they go and store that data, for protection, that data is that those applications are completely mutable, so no bad actor will be able to encrypt it or delete it, meaning, encrypt the data, and so on. Another thing that it was important is, so now it's immutable, my data is immutable, but what about when I need to have access? So one of the things that it was not talking here, it was tape. So they did have copies somewhere else in tape, but that copy that I was in tape somewhere, it was very difficult for them to read back, to the point that it took weeks to be able to restore that data, those applications, which some of them they were not able to restore. So having an application that allows, a process that allows incremental backups, that provides that efficiency and resource saving when you do your backups, what that means is that you only change what you need to change. That is super important from that perspective. The third thing is, so having mutability, I set up my backup solution, but what about where that data, where those applications get stored, where that Kubernetes environment, those backup get stored? It's very, very important to understand that storage solution. Right? I need a storage solution in where I will be able to scale without any limitations. It will be able to support any disaster recovery type of or architecture. Not only that, but it will give you the ability to be able to access those applications, those backups from anywhere, anytime, and most importantly, being able to do fast and being able to restore fast. And outside, a very expensive type of environment, the only solution that will provide that will be an object storage solution that will provide you that flat namespace where you can put all those Kubernetes backups in there, and you have you don't have to deal with any sort of limitation in what you can do. And lastly, and this is what Julia's talked about, it is a lot. It is important to have in place a Kubernetes-native backup and restore tools. It is super important to have those tools set up to provide that streaming that backups and being able to restore recovery processes and being able to go back to online fast. So the rapid recovery in one way or the other, they were able to do full recovery in hours. So they did, I think it was pretty awesome. I think every single company should do that. So let's try to simulate this again, and let's see what will happen. So when they simulate an attack, again, within that type of infrastructure they're set up, they will be able to recover in hours. We're talking about, I think this customer has a bunch of servers, but if you think about 3 servers infrastructure, you can do like 8 terabytes to 12 terabytes an hour. If you put all flash in there, you can 2x that. So this is hours, no days, no months, hours. Being able to go back to business in full recovery. Being able to have minimal disruption in terms of business operation. Being able to have an environment where if something bad happens, they will be able to restore right away. Being able to talk about what we want, fast restore, and fast backup. So by having immutable backups, being able, so no bad actor will be able to modify and delete the data, that's great. So now they set up those backups for those Kubernetes applications, no one will be able to delete it. But then who cares? What about those people that they don't want to change it? They just want to steal it. They just want to disrupt. So by having an object storage solution where when that data goes through the network, data in flight encryption, you have encryption mechanism. Not only that, when a bad actor is trying to disrupt by shutting down a server or shutting down disk or trying to get to those disks, this object storage provides that distributed architecture that doesn't matter. It gives you that 100% availability. If server goes down and this goes down, it doesn't matter. You will still be able to back up your Kubernetes. You will still be able to restore the Kubernetes. As I mentioned before, having a tool that will allow you to be able to back up all those Kubernetes applications in a rapid manner, in a very efficient way. And lastly, network optimization. There will definitely some issues within their network that they needed to make some changes to make it optimized in terms of security, but most importantly in terms of performance and the throughput that it was giving into those servers. Those are the things that it was in place and provide that rapid recovery to this specific customer.
So to maintain business resilience in Kubernetes environments, we were talking about it, prioritizing the protection of core data services and ensuring the recovery capabilities are essential, considering the potential downtime of ransomware attacks or even other type of disruptions. So why backup Kubernetes? Obviously, first, protect your stateful applications. Backing up is not, we talk about not needing to back them stateless applications, but we run stateful applications as well on Kubernetes. So ensuring the recoverability of business critical applications like a database, message queues. Supporting disaster recovery is another reason why we should back up our Kubernetes clusters, so we can restore everything quickly in terms of hours, not days, not weeks, because all of these means money at the end of the day. And again, ensuring business continuity and compliance. Compliance is something very important depending on the industry that you work on. So getting reporting, getting everything that you can show that you're complying to your industry regulations. All of that, backing up helps you with all of that.
And why object storage for backups? Number one, as I mentioned, is scalability. It provides you for you to being able to dynamically grow your Kubernetes cluster without hitting any sort of limitation. Also, as I mentioned before, that immutability, or most importantly, honestly, I can say immutability / that cyber resiliency, that you will be able to provide not only immutability, but provide security across all the different layers of that object storage solution. From the moment that you integrate with the backup solution that you're using to protect your Kubernetes, when you go through the network, when you're sending that data through the network, to have all those encryption in mechanism, security mechanism, all the way when it gets to the storage itself, those disks where that data gets distributed locally and across the server, so if something bad happens, you still have access to that data. Also provides you that being able to access that data from anywhere, anytime for that DR type of infrastructure. And lastly, gives you the capability of provide that locking that operating system. No bad actor will be able to root access to that system. So making sure from that high availability just to be able to provide that. And lastly, pricing, right? Every single one of our customers, they're asking for something, every single one or some of the people that we talk to, Candida, all we want is fast restore, fast backup at a lower cost. And that's exactly what object storage provides. So the key takeaways before I show you, before we show you how we do this, is number one, implement, and if you want, a comprehensive Kubernetes backup and restore solutions. Please, there's a lot of people, they don't take this into consideration, or maybe they take it in the development cycle until the last step. Please, it's very, very important, especially these days when that Kubernetes environment is going to keep growing. Leverage immutable backups. It's important, but immutability is not enough. If immutability was enough, why we're still paying billions of dollars ransomware payment? You need more than immutability. You need an object storage solution that provides those capabilities that I mentioned before. Also, design to edge constraints, right? There's definitely, when you're looking at your connectivity, the network connectivity of those edge to core to cloud, take into consideration a lot of the things that you will need to do to make that network efficiency, and be very proactive, prioritize in your security measures. You want to say something about that? So let me show you. Can you guys? Just 1 second. Of course. Okay. Okay, guys. So, let me mirror. There you go. Slideshow.
Hello and welcome. In today's demo, we will show you how simple it is to integrate Kasten with Scality Artesca. Let's start with this overview screen of the Artesca UI. Here we can see there is a single server Artesca in one data center. We can also see that storage services, meaning things like data protection, are available. Data services are also available and healthy. This is the S3 endpoint we will use to integrate with Kasten. We'll take a note of this to use later. In general, the system is healthy. Next, let's go into the data management section. Here we can see an account we have already created. An account is a secure collection of Artesca resources, such as IAM users and policies needed to connect to the application. We have created an account called Test K10, which is the account that Kasten will use to connect to Artesca. Kasten will need a bucket to store its data in. Let's click the data browser. We have created 2 buckets under that account. The first is for non-immutable data, and the second is for object lock protected data, so that no bad actor will be able to modify the data until the retention period is met. Another thing that is super important to create is a user under the account. We have created an IAM identity and access management user for the Kasten application to connect to Artesca. We then have to create some IAM policies for this user. By creating these policies, Kasten will be able to access the Artesca S3 repository and will be able to manage that data. So we have these 2 policies, one that doesn't have immutability and one that has object lock permitted. Let's click edit on the immutable policy so you can see what is in there. Here is the name of my policy. We can see all of the permitted actions we are configuring against the specific resource of the bucket we are using. We then attach these two security policies to the test 10K user. So those are the main things that we have to do. So Kasten, or that specific user, will be able to access the S3 storage to back up and restore data to and from those buckets. So now that we have everything set up from the Artesca side, let's go to the Kasten interface. Here we have 3 applications that Kasten is managing, and we'll back up one of those applications. In Kasten, we need to create a location so it knows where it is going to back up to, in other words, where the repository for that data is located. Let's click into the immutable location. As you can see, the configuration is super straightforward. Here we have entered the bucket name of the immutable bucket we created on Artesca earlier. We also list the endpoint we noted at the beginning, and for the demo, we have SSL disabled, but in production, customers will have it enabled. We have object lock set on the bucket, but we need to tell the application what retention period to keep the locked objects for, because the application controls this at the object level. Here we have selected 12 days. So this is all we have to do to connect Kasten to Artesca. Let's also see how the non-immutable bucket is configured. We can see the bucket name is different as we are using a bucket with different settings, but the endpoint remains the same as they are using the same Artesca. Finally, immutability is disabled for this location. So we have the 2 locations set up, and now all we have to do is create a policy to associate the application to be backed up with the immutable location. There are already some policies created. Let me show you the policy that backs up the PostgreSQL application to the immutable Artesca location. We have given it a sensible name, and for this demo, set the frequency to on demand. All we have to do once we enable backups via snapshot exports is to enter the location profile we created earlier, and here we add the application. Now that everything is set up, we can click here to run the policy. Then we're going to go to the dashboard, and we can see the system is creating the snapshot and going through the process of backing up the data. Whilst we are waiting for the backup to run, I should tell you that all the Artesca and Kasten integration instructions are precisely described in the Artesca documentation, and soon this will be automated by an assistant similar to the existing one for VBR and VBM 365. And now that the backup has had a chance to run, we can see from the dashboard that it has completed. If we click back to Artesca and then the data browser and follow some of these directories, we can see Kasten has written information into the immutable bucket. Coming back to the bucket level, we can use the search box. Let's use the last modified date. We see all the individual objects saved into the directories that make up the component parts of the backup we just saved. The padlock icon indicates they are protected with object lock, fully immutable, and protected from ransomware attacks. We can see when the retention period ends here. To summarize the demo, we have seen how simple it is to set up Artesca resources and how easy it is to connect to Kasten. Thank you for your time.
So those are just tools, just to show you where or you can download every single one of them. You can definitely download Kasten. Oh, I'm sorry. You can definitely download Kasten as your backup tool. And of course, in Artesca as an object storage tool. Again, this is just 2 examples or some of the tools that are, that are definitely available, but you can see how easy it is to secure your data right away.
And both tools are based on open source projects. So Kasten is based on Canister, which is a CNCF open source project. And Artesca is based, Artesca is also another open source project. So you can try them out, and if you have any questions, we are here throughout the week. We have 1 minute, I think, and I have another talk right now. So, but feel free to connect with us if you want to talk more about that. We are passionate about backup, object storage, and edge as well. It's a topic that we've been, discussing a little bit more between us, and I hope you enjoyed it a little bit. Thank you so much.
Thank you.
No time for Q&A? No?
So I'm going to be around. Julia has to go for her next session, but I'm definitely going to be around if you guys have any questions.
Thank you.